You know, there's a hidden property of light that's all around us, but you can't actually see it. It's called polarization. And believe it or not, you use it every single day. It's the secret sauce behind your anti-glare sunglasses, and it's the magic that powers the very screen you're looking at right now. So let's dive in and unlock this invisible world. All right, here's our game plan. First, we're going to uncover light's secret direction. Then we'll figure out how to tame its wild waves. We'll look at 2 really clever ways to do this, see how that powers the tech in your pocket, and then we'll wrap up with a look at this bizarre crystal that literally gives light double vision. It's going to be cool.
So let's start with this simple but really powerful idea. When you look at light, you see brightness, you see color. But there's something else going on that you don't see, the direction that the light waves themselves are vibrating. It's a hidden property that changes everything.
I mean, really think about it. Some sunglasses don't just dim the world, right? They completely zap that blinding glare you see coming off a wet road or the surface of a lake. It's like they're only targeting the glare itself. So how on earth is that possible?
Well, the secret is all about polarization. It turns out that glare is just light that's gotten, well, organized. All its waves are vibrating in the same direction, horizontally. Polarization is our way of creating a filter that's like a gatekeeper. It only lets light through based on its direction, kind of like a comb only lets through hairs that are lined up with its teeth.
So, that brings us right to the core of it. What does it actually mean to polarize light? Let's get into the mechanics of how we can tame these invisible vibrating waves. Okay, this picture shows it perfectly. Light from the sun or a regular light bulb is unpolarized. That means its waves are just vibrating in every possible direction. It's total chaos. A polarizer, though, acts like a filter. Maybe think of it like a picket fence. It only allows the light waves that are aligned with its vertical slots to get through. Everything else, blocked. Just like that, chaos becomes order.
And here is the official scientific definition. Now, it sounds a little complicated, but it's exactly what we just saw. That electric vector part, that's just the fancy term for the direction the light wave is vibrating. So all polarization means is we're taking all those random vibrations and forcing them into a single, organized plane. That's it.
So how do we actually make this happen? How do we create this neat, orderly, polarized light? Well, it turns out there are 2 main ways to pull it off. Let's look at the first one, which builds right off what we were just talking about.
The first and maybe most obvious method is polarization by transmission. This is our picket fence idea in action. You just create a material that has these microscopic slots and then you shine light through it. Only the light that's lined up the right way gets to pass through to the other side. Simple as that.
Now, this is where it gets really clever. So you've passed light through one polarizer. What happens if you add a second one right after it, which we call an analyzer? Just look at this diagram. By rotating that second filter, you can basically use it like a dimmer switch for light. If the 2 filters are lined up, light comes through. But if you rotate that analyzer 90 degrees, its slots are now sideways compared to the light's vibration, and it blocks pretty much everything.
And of course, there's a law for this in physics. It's called Malice's law, and it's the math that lets us predict the exact intensity of the light just by knowing the angle between those 2 filters. It's this perfect formula that proves that the angle is everything.
But you don't always need a man-made filter. Turns out, nature has its own way of polarizing light, and it happens all the time. Every time light bounces off a surface. This is called polarization by reflection.
And this brings us right back to our sunglasses. When chaotic, unpolarized sunlight hits a surface like water, the light that reflects off it becomes horizontally polarized. That's the glare. And what's really amazing is that there's a kind of magic angle. It's called Brewster's angle, where that reflected light is perfectly horizontally polarized. So now that the glare is all organized in one direction, your sunglasses, with their vertical polarizers, can block it completely.
And yep, physics gives us the precise formula for this too. Brewster's law lets us calculate that exact magic angle for any material out there. All you have to know is its refractive index, which is just a number that tells you how much that stuff bends light.
Okay, so this is all some fascinating physics, right? But here's where it stops being theory and becomes part of your everyday life. These principles are the engine behind the very screen you are looking at right this second.
So what you're seeing here is a simple diagram of a liquid crystal display, or an LCD. And what are the first and last things you see? Our old friends, the polarizing filters. The entire technology, the whole shebang, depends on being able to cleverly control polarized light.
So here's how the magic trick works. Light from the back of your screen goes through a polarizer first. Then it hits this layer of liquid crystals. When there's no electricity, that's the off state, these crystals naturally twist the light's polarization by 90 degrees. That twist allows it to pass through the second polarizer, and boom, the pixel is bright. But when you apply a little voltage, the on state, the crystals straighten out. Now the light's polarization isn't twisted, so it gets blocked by that second filter, and the pixel goes dark. Every single picture on your screen is just millions of these tiny light switches, all being flipped on and off by controlling polarization.
Okay, for our last stop, we're going to move away from everyday tech and look at something that is just truly bizarre. Let's see what happens when light goes into a very, very special kind of crystal.
No, this is not a camera trick. What you're seeing is real. When a single ray of unpolarized light enters a calcite crystal, it actually splits into two separate rays. This crazy phenomenon is called double refraction. The crystal literally gives the light double vision. And what's even wilder is that each of these new rays is now polarized, but they're polarized in different directions from each other.
And these two rays are not created equal. The first one is called the O ray, which stands for ordinary. It behaves itself. It travels at a constant speed. It follows all the normal rules for how light bends. But the second one, that's the E ray for extraordinary, and it's the rebel. It travels at different speeds depending on which direction it's going, and it just doesn't obey the standard laws of physics for light. It's an absolutely stunning reminder of how weird the world can be.
So, we've seen that light is so much more than just a simple beam. It has this hidden orientation that we can filter, that we can control with electricity to build entire digital worlds, and they can even be split in two by a cool-looking rock. It really makes you wonder, doesn't it? If light can be filtered, bent, and even split in two, what other secrets is it hiding?